Sorry guys, I don't know how the meeting got ended. So let's wait for a couple of minutes to join other people. Hope I am audible to you guys.
Yeah.
Okay. Okay, all right. Let me share again. Where were we? I think I was telling you that at each LAN segment, okay, our IPs are intact till end to end. I mean source till destination. However, your source MAC and destination MAC are getting revised at each segment or at each broadcast domain or at each layer 2 segment, I would say. Okay, your source MAC and destination MACs are changing. Okay. Anybody have any questions? Why, I mean, where it is sending R, it is getting that reply response back. Any questions in this packet flow diagram? Is everybody clear? Because this is just a basic, everybody should have this understanding. NRC is mostly around troubleshooting your things, why they are not working. So unless until you have your basics clear, it will be not easier to troubleshoot any network scenario. Right? I hope it is clear to everyone. Okay, let's move ahead. Next concept comes out to be your administrative distance. Okay, our routing information that our router is storing in its routing table that can be populated by multiple means. Okay, may it be a static routing, may it be a dynamic using any dynamic routing protocol, may it be various kinds like EIGRP, BGP, OSPF, ISIS, okay, and RIP, anything else. So what is AD playing as a role over here? Okay, so AD is your trustworthiness of a routing source. Routing source, I mean to say these protocols by which I'm learning our routes and storing it in our routing table. Okay, so there is a preference value, we can say, or the trustworthiness value of each method by which we are learning our routes. That is known as administrative distance. Okay, for comparing between two different sources, let's say from two different sources, I'm receiving a route. Which one will be more preferred or which one will be stored in my routing table? That will depend upon the value of this AD. Okay, least AD value is more preferred. Okay, so preference is increasing in this order. So most preferred is if it is a connected interface, then comes static and then so on and so forth. Okay. EIGRP does have several kind of routes. EIGRP internal, EIGRP external, and your EIGRP summary route. We will go through all of these. But EIGRP have multiple types of route. That's why they have their own different ADs. Similarly, for BGP also, if it's a eBGP route, we have a different AD. IBGP route, we have a different AD. Okay, same route. If we are receiving via multiple routing sources or multiple protocol, that will be the least AD will be more preferred, and the higher AD will be less preferred. Okay, if let's say we are putting a static route, a static route AD by default, it is 1, but we can change that AD also. All these AD values that you can see over here, these are default AD values for each protocol or for each method. However, if we want, they can be changed also. But the changed AD value is local to the router. Okay, for example, if on R1 I am configuring a static route, okay, and that with a different AD other than 1, so that is local to my router. Similarly, if let's say on this router I'm running a routing protocol RIP, okay, and I'm changing the AD value of RIP, okay, so that is local to this router. It will not be, this AD value is not advertised to any other router within your routing protocols. This is a locally significant feature. All right, any question, guys? All right,
Yeah,
let's say one question from my side. Let's say you, you want to or let me open a text box. Okay, let's say you want to match or you want to look for a route for 10.1.2.3. Within your routing table, you have these routes pointing towards, let's say, FA0 by 0. Okay. Next is 10.1.0.0/16 pointing towards FA0 by 1. 10.1.2.0/24 pointing towards FA0 by 2. Then there is another route pointing towards FA0 by 3. Okay, this is having an AD value of, let's say, 10. AD value 20, 30, 40. Okay, now I want to send a packet to this one. Okay, firstly, our routing table, it works or it sees only the destination IP address. Within my packet, I do have this source IP, I do have this destination IP. Okay, on my router, which IP I will check in order to route that packet? Only destination IP address I will check. I hope this is clear with everyone. Okay, it does not check the source IP, right? So within this, let's say this is our scenario. Within my routing table, I have these routes. In order to reach this destination, which route it will take?
Last one.
Last one. Why is it so?
Precise the route.
Sorry?
Means it's like it's the correct most, what do you say, most precise one.
Most precise one, yeah. Longest match, or we can say, right?
Yeah.
Yeah. Just I wanted to bring this to you. Longest match prefix. Always in your routing table, if you want to match any route, this is always the first criteria. Longest match prefix. Now, if it is having the same thing, let's say I'm having these two routes. Okay, out of these two, now think through it. This is my routing table. I have these two routes. Now, which one will it prefer?
First one.
First one, right? So, I mean, this will be my first criteria, and our second criteria will be lowest AD. This will be our second criteria. Okay, I hope this is clear to everyone. Okay, and these AD values, what I was showing you, these are the default ones. We can change them also. There are methods. Okay, we'll go through it. So this was just basics of your IP routing. I wanted to brush up with you guys. Now let's move to EIGRP. We'll start with EIGRP today. Okay, so EIGRP full form is Enhanced Interior Gateway Routing Protocol. Okay, earlier, I mean, before EIGRP, there was a protocol named Interior Gateway Routing Protocol, IGRP, named as IGRP. This is the enhanced version of IGRP. Okay, this was a Cisco innovation, but I mean, Cisco proprietary earlier, but later on, it was made as open standard. So not only Cisco, nowadays, few other vendors also have this as a routing protocol in their own boxes. Okay, it uses your hello protocol, okay, to form your adjacencies or neighborship among two different routers. We use a hello protocol between those devices. It sends your partial updates. Okay, however, I mean, since it's a enhanced distance vector routing protocol. Okay, can anyone tell me what is the difference between a distance vector and a link state routing protocol? Anybody?
Hop based on
Distance vector versus link state. Okay, you said hop based. Which one is hop based? Distance vector. You are saying it's hop based. Okay.
And the link state will be like, it will be having the entire topology based on to decide.
Entire topology, you said. Okay.
Okay,
What else?
For this distance vector, EIGRP work on the distance vector and OSPF work on the link state, right?
Yes. Example is OSPF ISIS. Okay. Distance vector, I would say WIP, IGRP, EIGRP. Anybody else would like to contribute? Any other difference? No. Okay. So as you said, this is hop based. So okay, point is correct. Within distance vector, each router will advertise its complete routing info to its neighbors. Do you guys agree? For example, this is R1. Okay, this is R2. Both are connected via this link. Okay, let's say this R1 does have a couple of more interfaces. So what R1 will do is, and let's say they are running RIP as a routing protocol. I'm not talking about because these both protocols, distance vector or link state, they are part of your dynamic routing protocol, not static. Okay, so we are talking about dynamic routing protocol. So they are running, let's say RIP we have configured. So how RIP works is it will create a database. Okay, within RIP you know very well that we do not have any neighborships. Okay, although RIP is not in our syllabus, I'm just trying to make you understand the difference between distance vector and link state. So what it will do is R1 will put all these interfaces, if they are running RIP onto it, it will keep them in its routing table and it will advertise as a RIP update request towards all the links. Okay, RIP sends its database towards all the links on which RIP is working. That's how it works. So same way I'm saying each router will advertise its complete routing info to its neighbors. And same way R2 will also advertise. So when R1 learns, okay, what all subnets lies behind R2, it will keep them in its, or it will update its routing table. Okay, but whatever I'm learning from R2, same I will not send back to R2. Do you guys agree? Within distance vector, we use this behavior. Whatever I learned from this interface, same information I will not flood back, or I will not advertise back from the same interface. Right? What this feature is called? Split horizon. Exactly. Okay, this feature is known as split horizon. So this is basically a loop avoidance mechanism in your distance vector routing protocol. Right?
Sorry.
Yes, Pramod.
Actually, I missed 30 minutes of session already.
Okay.
Can you what is this split horizon?
Okay, I'll no worries. So Pramod, before this, before EIGRP, I discussed about the layer 3 packet flow, how it works. You can watch that recording, but I'll rephrase around. I was talking about what is the difference between our distance vector routing protocol and link state routing protocols. Okay, so within distance vector routing protocol, these are our examples: RIP, IGRP, EIGRP, and we are saying that within distance vector routing protocol, each router will advertise its complete routing info to its neighbors. However, in case of RIP, you do not have any neighborship protocol. So in RIP, what it does is it sends a multicast update on all the interfaces on which RIP is running. Okay, so for example, R1 sends some update on this interface. Okay, and R2 learns that same update over here on this interface, let's say. Okay, now R2 will not send the same update back towards R1. Okay, let's say that R1 was having a loopback configured as 1.1.1.1. Okay,
this is
R1
protocol, right? This is
RIP
protocol.
RIP, or in general, you can assume any distance vector routing protocol.
EIGRP. Okay.
Yeah, in EIGRP also same behavior happens. Let's say R1 advertised information about this loopback towards R2, that I am the owner, or if you want to send any data for 1.1.1.1.1, you can send it to me. Okay, R1 is advertising this towards R2, and R2 learns that on this interface. So R2 will not send back this information for 1.1.1.1 from this interface. But let's say if R1 does have another connection towards R3, then that information R1 will float towards R3. That is okay, but not back towards R1. This is known as split horizon rule.
So it is just one way broadcast communication, right? That hello message.
No, it's not hello. No, sorry. This is not hello. This is beyond hello. Okay. In terms of EIGRP, hello protocol was being used to form your neighborship.
Yeah, right.
Okay. Once you have formed your neighborship, then what you want to do is you want to send your routing updates to your neighbors.
Right.
Okay. Let's consider this as EIGRP. So split horizon rule applies to your routing updates that you are sending to your neighbor.
Oh, okay.
Okay, so that is basically when split horizon is acting as your loop avoidance mechanism. Otherwise, it will be a wrong information. R1 is advertising towards R2, and R2 will also say, okay, if you want to reach to 1.1.1.1, send it to me. That's not a correct information. It will create a loop. Packets will keep on looping between R1 and R2. Okay, split horizon is the loop avoidance mechanism in case of your distance vector routing protocol, loop avoidance. And please remember this line: each router will advertise its complete routing info to its neighbors. Okay, but in case of your link state routing protocol, how this line is differing is each router will advertise its or I would say info about its own links to its neighbors. In case of OSPF, how it happens, I mean, let's say this is R1. Okay, R2. And let's say they are forming OSPF neighborship among them. So R1 will advertise, okay, I have these two links. One is, let's say, this loopback 0, and one is this interface. It will create link state advertisements, and LSAs will be advertised within the area or outside that area, depending upon if it is an APR or it's an internal router or whatever it is. It will just advertise information about its own links. That's it. Okay, in the form of LSAs. Once each router got, okay, R1 does have 2 links. Let's say R2 is advertising, I have 4 links. And what is to which it is connected, what is the subnet IP or whatever information I'll just advertise whatever is my local interfaces. I'll advertise that. Based upon that information, each router will run or will perform a SPF calculation, shortest path first algorithm. It will run and form its routing table. That's why it is known as link state routing protocol. It is advertising information about its own link. What is their state and what is the description or link type, whatever information it does have about its own links. Is this clear to everyone? I mean, difference between distance vector and link state. So how loop avoidance happens in link state? Here we were using split horizon. Anyone? Guys, please participate. Yes, no, anything else? Any idea how loop avoidance happens in link state routing protocol?
We need to configure the interface as a passive.
No. Passive is, I mean, passive concept we have in EIGRP RIP also. In almost all the dynamic routing protocols, we have passive interface capability. That is different. We will go through it.
We will understand on which link of other router that network is residing.
Basically, there are a couple of things, okay, to avoid the loop. Main one is your SPF algorithm. Let us start first. That is avoiding your loop in case of OSPF. Here it is split horizon. Okay. Otherwise, I mean, from scalability perspective, in OSPF, we divide our topology in different areas also. Okay. Area 0 is a must in case you want to have multi-area communication. You must have area 0 that otherwise your non-area 0 will not be able to communicate with each other. Area 1 cannot communicate to area 2 without having a link with area 0. Okay, that's where it forms an inverted tree kind of structure. All right. I hope this is clear to everyone, the distance vector versus link state routing protocol. Okay, coming back. So in distance vector, I'm saying that each router will advertise its complete routing info to its neighbor. This is the basic definition or feature of a distance vector. However, EIGRP we call as enhanced IGRP or modified version of distance vector. That's why I'm saying it advertises only partial updates. Okay, it is not sending all the updates or complete routing information to its neighbor. It sends the partial updates, whatever is required from my neighbor. if there is any change, I mean, usually in distinct vector, for example, right, after every 30 seconds or so, you will send your complete routing table towards your neighbors, or you send it at a multicast destination address. However, in case of EIGRP, you only send the partial updates. That's where it is better. I mean, it's more optimized version, I would say. Okay, and what other features do we have? Load balancing. It can support equal cost load balancing and unequal cost load balancing. Both kind of load balancing it can support. Okay. However, your OSPF can only support equal cost load balancing. Multi-address family, it can support IPv4 as well as IPv6. Few others as well. Loop free. To avoid the loop, it does have split horizon, and that dual algorithm also it supports. Classless routing protocol. It does supports your variable length subnet masks. Okay, I mean, it's not restricted to your class A, class B, and class C only. You can have subnet mask at any length. It advertises your subnet mask of the interface while forming the neighborship. Okay, it advertises that also. Rapid convergence. Why we are saying it can be converged rapidly? Because it uses that dual algorithm to and it keeps the backup path in its topology table. Okay, as we'll go through all these concepts. I'm just telling you the brief about EIGRP. Reduced bandwidth usage. So we just now see that it only sends the partial updates, not the complete updates. So that's where we are saying it reduces the bandwidth usage from control plane perspective. All right. Anybody have any question?
Classless routing protocol. What does that mean?
So when we advertise, when we run EIGRP, okay, on our router, how we configure is we configure network statements under router EIGRP. Okay, this interface, it's not necessary that it does have either /8 IP address or /16 IP address or /24 IP address. Okay, these are our default classes: class A, class B, class C IP addresses. Okay, it may have, let's say, a /28 IP address or /30 IP addressing. Okay, so while advertising routes, it will advertise this subnet mask also. So we can have variable length subnet masks we can configure. However, in case of RIP version 1, you cannot do that.
Oh, okay.
Okay, let's say these two interfaces are there and they both belongs to class C IP address, same class C, but they both have /28 IP address. One of them you want to part of EIGRP, other one you do not want. So you can easily specify the wildcard mask along with the network statement. While doing lab, I'll show this to you. Otherwise, that's what it means, classless routing protocol, because it advertises the subnet mask also along with the advertisements. Okay. Okay, so this is about how EIGRP operates. Okay, first is your R1 and R2 when we have configured EIGRP on R1 and R2, and we have specified that using network statement, we have specified that I want to run EIGRP on this particular interface. What it will do is it will exchange a hello packet between each other. R1 is sending towards R2. Okay, I'm router R1. Same way, your R2 is also sending the hello information over here. Okay, once your hello packets have been exchanged and your neighborship has been through, then they will exchange your update packets. They will exchange your routing information in terms of in form of your update packets, and each update packet will be acknowledged back also. This is a reliable protocol. RTP is, you will also hear uses reliable transport protocol, in which our delivery of packets is guaranteed and it's ordered delivery. Basically, they do have a sequence number with which they maintain the ordering, and the guaranteed delivery is maintained using these acknowledgement packets. Okay, for example, this this router sends an update packet. Okay, it will basically acknowledge that packet also. Same way, this R1 is sending that packet towards R2. R2 will acknowledge that packet. So that's why we are saying it uses reliable transport protocol, which ensures your guaranteed and ordered delivery of packets. Okay, EIGRP supports both multicast and unicast for your hello packets and your update packets. Usually, by default, it uses this multicast address for your IPv4 communication 224.0.0.10, and if we are using it for IPv6 protocol, then it will use this as a multicast address in order to send hellos and your update packets. Okay, it runs directly above your IP layer using IP transport protocol number 88. Okay, we'll see this thing in the Wireshark output also. Any questions till now?
Neighbor table is the direct connected interface information.
Exactly. Yes,
and topology,
exactly.
all the interface connected to particular router.
Okay, not about interfaces. Neighbor table will show you, for forming the EIGRP neighborship, you should have a direct connectivity. Okay, it cannot happen that, let's say, R3 is connected over here. R1 and R3 cannot be the neighbors because they are not directly connected.
Yeah.
Okay, so neighbor table will store, okay, which all are my EIGRP neighbors, what is their current state. Okay, now when you have sent your update packets, when you have exchanged your updates, routing updates, then it will, they all will be stored in the topology table. Okay, and the best routes from your topology table will be stored in your routing table based upon the metric. Let's say R2 is advertising or it is having two links with R3. So there will be two different neighborship. Okay, out of them, only one of them will be or the best route will be stored in the routing table, but your topology table may have more than one route for the same destination. Let's say there was a destination over here, 3 dot something. Okay, so this destination is being learned via both the neighbors, both the neighborships. So in your topology table, you may have more than one route for this subnet, but in your routing table, it only the best route will be selected and put in your routing table from your topology table.
Okay.
Okay, as soon as this best route goes away, dual algorithm will run again, and from your topology table, your next best route will be copied to your routing table. This is very quick. That's why we are saying EIGRP is having a rapid convergence, because it keeps your multiple copies of routes in your topology table. It stores them. Your backup routes are also stored. All right. So moving ahead, this is a summary of all the features what we have in EIGRP. First is it uses IP protocol number 88 as your transport protocol. It implements its own reliable RTP protocol, reliable transport protocol, in providing reliable unicast and multicast packet deliveries. Okay, metric. All these topics they will be covering in detail also in the upcoming slides. This is just a feature summary. Okay, metric, we consider by default a bandwidth configured on the interfaces and your cumulative delay. I mean, between your source and destination, the cumulative delay or the addition of delays will be considered in order to calculate the metric. Constrained bandwidth means the minimum bandwidth is considered while calculating the metric. Optionally, we can use load, reliability, and MTU other parameters also. Optionally, they can be used but by default, your bandwidth and delay are used to calculate the metric of an EIGRP route. Okay, hello interval and hold down timer, they are used while forming the EIGRP neighborship between two routers. At a certain interval, each router will send hello packets towards its neighbor. Okay, that is known as your hello interval. Okay, same way, 3 times of your hello interval is by default acting as your hold down timer. If after that hold down timer has expired and it is not receiving an acknowledgement or hello from a neighbor, it will declare that neighbor as down or failed. Okay, and it will flush all the routes learned from that particular neighbor from its routing table. At what destination address I'm sending my routes? Since I said that normally it uses the multicast addresses. For IPv4, it uses 224.0.0.10. For IPv6, it uses this multicast address. Okay, but we can form a unicast neighborship also. I'll show that. Okay, full or partial updates. So in the beginning, it will send the full updates. Once it is done, I mean, both the neighbors have exchanged their complete routing tables, then post that it will only send the partial updates. Okay. It supports authentication. I mean, we can configure an authentication also so as to avoid any malicious or rogue router to form neighborship with our own infrastructure devices. So there are 2 types of authentication that it does support: MD5 and your SHA-based or HMAC-based authentication it does support. VLSM or classless, same that we discussed, that it includes the mask configured with each route while advertising. Okay, so it does support your variable length subnet mask or discontinuous networks also. Route tagging also it supports. I mean, we can tag certain routes to avoid the loop or filter our routes. Okay, that route tagging is also possible. We will definitely see this. This is in our syllabus. Next hop field. This is important, guys. For example, we have a router, let's say R1, forming a neighborship with R2. Okay, R2 is further forming an EIGRP neighborship with R3. Okay, and let's say R1 is having a route or let's say loopback is configured that is being advertised in EIGRP towards R2, and R2 is advertising towards R3. So on R3 routing table, if I see this 1.1.1.1, okay, what is the next hop IP for this route? Can anybody tell me?
Next hop IP4
For
R1.
this route in the routing table of R3.
R2.
R1.
Why R1 and why R2?
Because R3 learns this route from the R2's interface. R2 from the R2's update.
Okay, so by default, EIGRP, while sending updates to my EIGRP neighbor, I will change the next hop IP to myself. Okay, when R2 will advertise routes towards R3, it will change the next hop IP of this interface while sending to R3. If it is sending to, let's say, R4, okay, there is another router R4. On R4, it will be showing this interface IP as the next hop for same route. Is it clear with everyone? Pramod, any doubt?
Yeah, can you please repeat that again?
Okay, I'm saying, let's say this R1 is originating this route. Okay, and we are running EIGRP among all four. R1 advertise this to R2.
Right.
R2 will send it towards R3 as well as towards R4. But while sending it to R3 and while sending it to R4, it will change the next hop IP to its own interface IP address. This is the default behavior of EIGRP.
Yeah, that's correct.
Right? So, and on this R4, if I check, the interface will be R2 interface. Let's say this is your E0 by 0, or let's say E0 by 4. And this is your E0 by 3. So here it will be IP of E0 by 4 R2 interface as a next hop.
Yeah, this is normal.
This is normal.
Then, yeah. Then
What?
how
Hmm.
next hop field? What is that actually?
Sorry, what's the question?
Then what is this statement about different
Correct.
next hop
So
router?
this statement says that we can change this default behavior also.
Oh, I see.
We can modify this default behavior also. How? Let's say R1. Okay, and this is the multi-homed network, or one-to-many neighborship, or you can say hub and spoke kind of environment. R2 is forming neighborship with R1. Okay, and R1 is forming neighborship with R3 also. But R2 and R3 are not directly neighbors with each other. Let us assume. Okay, now what will happen? Let's say R2 is advertising this 2.2.2.2 towards R1. R1 will send it towards R3 also. Okay, by default, R3 does have this route 2.2.2.2. What will be the next hop?
R1.
R1. But should it be R1? But if because I can send that traffic directly to R2 without sending it to R1. It's possible because they are also connected on the same subnet. Right?
Mm-hmm.
So in that scenario, we may change to say no next hop self. We can do that. That's what this point says, that with a different next hop router than the advertising router. It supports the advertisement of routes with a different next hop router. R1 can send directly whatever I'm learning. R1 can send directly towards R3 without changing the next hop to himself. That's what I wanted to say. Okay, default behavior is router will advertise himself as the next hop. But this can be changed. I can say no next hop self. Is it clear?
Yeah.
Okay. Route summarization. Yes, we can summarize the route at any point in EIGRP network. Okay, so in EIGRP, summarization can be configured at an interface level. Okay, at an interface level, I will configure and summarize the networks being advertised from here. Okay, we'll have a lab for this also. However, in case of OSPF, you can summarize only at your ABR router or your ASPR router. These are the only two places where you can configure your summarization in OSPF. However, in case of EIGRP, it can be configured anywhere, but at an interface level. Okay, multi-protocol, yes, it can support IPv4, v6 also. Earlier implementation could have support IPX or AppleTalk, but we will not talk about that. Okay. Any doubts till now? before we move further. Clear? Okay. So these are some of the, or I would say, EIGRP packet types. Hello packet. How we are using hello packets in order to form your neighborship and to discover your neighbors. Okay. At what IP address these hello packets are sent? Can anyone tell me? Are they unicast or are they multicast?
Usually multicast, but can be unicast as well.
Right. So we can send what's the multicast IP address? 224.0.0.10. Okay, that's where I will send my hello packets. Okay, and they are used to form your neighbor adjacency. Update packets. Once I have formed my neighborship, I'll send the update packets to send the routing information or to exchange the routing information with my neighbors. They are sent reliably means you will get your acknowledgement also. Okay, guys, please remember only hello and your acknowledgement packets are not reliable. Otherwise, all the rest of the packet types are your reliable packets. You will get the acknowledgement also. You will have your sequence number also. Okay, it's not there only with your hello and acknowledgement packets. Rest of the packets are reliable. Reliable, I mean, you will get your acknowledgement as well as your sequencing over there. Okay, update packets can be sent to a single neighbor using your unicast, or it can be sent to a group of neighbors using multicast. Okay, update packets can be complete or can be partial also. First time they are having the complete routing info. Post that you will be sending only the partial updates, whatever change has been there in the network. Okay, query packets. I'll explain you in detail when we'll be doing the stuck in active scenario. So query packets, I would say that if when your EIGRP router has lost any route, okay, about a certain network and does not have any backup path. So from where this backup path is coming? From your topology table. Let's say in your topology table also you do not have any backup path. Then what it will do is it will send a query packets to all its neighbors. Okay, and it will wait for a certain time to get the response from all its neighbor against all the query packets which it has sent. Okay, when these query packets are being sent, when let's say a router has lost information about a particular network which was earlier part of its routing table, okay, and it was learned via EIGRP, and it does not have a backup path also in its topology table, then it will send a query packet towards all its neighbors, asking them if they have information about this particular network or not. And they will respond back if they have any route for this neighbor or for this route which has been lost or not. Okay, and it will put that route in an active state till the time it is waiting a response for all the query packets. Okay, we'll
This one,
Hmm.
let's say we have 3 routers, okay, and
Okay.
there are multiple network connected to those 3 routers.
Correct.
And suppose one of the network is missing, it's not
Right.
reachable. So it's
Right.
not reachable for all the 3 routers, right? Then all the 3 routers will start query to each other. Is that correct?
Yeah, let's say all of a sudden R1 lost some route. Okay, R1 was having a route in its routing table, and it loses that route. It goes away. So
No, actually,
it
I'm
will.
saying
Hmm,
there are other network connected to R3 or
Okay.
R1.
Okay.
There are three network connected, and that
Hmm.
one of the network is not reachable.
Hmm.
Right?
Okay. Let's say this was the interface which went down.
Yeah, correct.
Okay. So what R1 will send is R1 because it's a directly connected network for R1.
Mm-hmm.
So R1 will send the partial update.
Okay.
Okay. R1 will send a partial update. As soon as R2 was earlier having this route from R1,
Mm.
R2 was having this particular route. Let's say this was 1 dot something. Okay. Earlier R2 routing table was having this route and it was saying that next hop is R1. But now R1 has sent a partial update to remove that route from R2 routing table. R2 has removed that route. R2 has lost that information. But R2 will still send a query packet towards R3. Do you have any other route from R for 1.1.1.x? It may have, let's say, some connectivity via R4. It may have, na?
I see. Okay.
Right? So it sends a query packet to all its neighbors. And if they have any information about the lost network, they will send a response back. Basically converging the topology, nothing else. Till the time R2 will keep this network in the active state. That's how it happens.
Until R2 receive update back from R3, right?
Reply, yes.
Right.
Reply for your query packets.
Yeah.
Right? This query packet, this is your stuck in active query, basically, and stuck in active reply, SIA. Okay, and this is your reply packets. This query and reply, I think these are same. I should not write like this. Okay, and acknowledgements are, you are just acknowledging the receipt of an update or the query packets. Let me delete this one. Your acknowledgement packets are, you are acknowledging the receipt of your update, query or reply packets. Since these are reliable. Any questions on these different packet types? So in all, we have, I'll cancel these two. Okay, we have 5 types of packets in our EIGRP. Out of these 5, these 3 are reliable packets and hello and acknowledgements are unreliable.
Hello is only sent at the beginning, right? When we activate, when
While
we
forming the neighborship, yes.
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 When we
Neighbor
run this
discovery.
EIGRP
Correct.
command.
And post that also, if my neighbor is up, within each hello interval, it will keep on sending a probe messages whether you are alive or not. After each hello timer, it will exchange the hello packets.
So is it every second or what's the frequency?
By default, 5 seconds. By default, 5 seconds. 5 is your hello packet and your hold down timer is 15 seconds. But that can be changed at an interface level. Per interface, you can change that also.
What is usually per design? What is advisable? It's like default, right?
All right. Anybody have any questions in this different kind of EIGRP packets? Sorry.
No, sorry. I was asking like what is usually recommended, this hello timer values, 5 seconds. We usually keep it 5 seconds, or what is the usually, best practice?
Usually we keep it as a default. I mean, it depends on different scenarios also. I mean, but I've seen most of the time it is same.
Mhm.
See, understand the purpose. hello and hold down timer. What is the purpose of these things? Okay, their purpose is to converge your network basically. Let's say R1 does have a link which is connected to R2. Okay, and let's say there is another link with R3. This is hosting. This R2 and R3 are part of, let's say, same site, and they are advertising same subnet where you have your servers. Okay, now let's say this is your primary and this is your secondary. So after each hello interval, you are checking, okay, if a neighborship or R1, R2 both are reachable or not. Same way on R1, R3, they are checking. So the purpose is you want to check the liveliness of this neighborship or this adjacency. Okay, as soon as it is going down, let's say it is taking hold down timer of 15 seconds. Okay, so if it has gone down, it will take 15 seconds in order to move it to the secondary link, move the traffic to the secondary link. Okay, but if your application or your softwares or whatever you are communicating between these two sites, they are susceptible or they cannot tolerate this much of convergence 15 seconds, then you have to decrease this timer. Basically, this becomes your convergence time.
Right.
Okay, so it is all subjective based upon your requirements or customer requirement. But the use is to converge your network. Hello and hold down are being used to converge your network. Same way in your RIP, you are not having any adjacency or you are not having a neighborship. They were just sending the updates at a multicast address. And if they, on the other end of the link, if this router receives, it will update its routing table. Otherwise, it will keep on sitting as it is. Okay. So moving ahead, this one pretty much we have covered. EIGRP neighborship. Hellos are multicasted to this to address 224.0.0.10 in case of IPv4, and this is your IPv6 multicast address. 5 seconds is your default hello timer. Hold down timer is 3 times of your hello. 15 seconds is the default one. On an interface level, you can change these two values. These are the commands: IP hello interval EIGRP, and this the ASN number of EIGRP, and then you can specify your hello interval and your hold down timer. That's how you can specify. Okay, neighbor table, it lists all your directly connected neighbors along with their next hop router and the interfaces on which this neighborship has been formed. What is the state of that neighbor? It will also show. With 3 kinds of table we have in EIGRP. Second is your topology table. In topology table, it lists all the learned routes from your all EIGRP neighbors. Okay, there can be more than one route also for a particular destination. But in topology table, it will store all the routes along with their metrics and destination IPs. Okay, it will store that. However, the best routes from your EIGRP topology table will be copied to your routing table. Right?
Value 100. What is value 100 here? ASN?
100 is EIGRP ASN number, autonomous system number.
Yes, okay.
Just an example, it can be anything else also.
Yeah, you're right.
Okay. So in our classic mode, we define a number over here, but it okay, leave it. When we'll do the named mode, I'll cover that. Okay, so I told you that usually we use multicast in order to form the neighborship, but we can have a static EIGRP neighborship also. Okay, let's say R1 is connected to R2. That's how it is connected. So in our EIGRP configuration, we can statically define R2 as a neighbor of R1 and R1 as a neighbor of R2. Okay, that manual neighbor configuration can also be done. So in that scenario, they will not exchange the hello with each other. They will just form the neighborship. But understand, if on one side I am defining static neighbor, then it is necessary or it is must to define the static neighbor on the other side also. Okay, otherwise they will not be able to form your EIGRP neighborship. So that's what this line says. Either all neighbors on a common network segment are statically configured for each other, or none of them are. Okay, so on both the sides, I'll have to configure the neighbor statement. Because what's happening in the background is when we configure a neighbor statement on this interface or this R2, it will not send, or it will stop sending the hellos from this neighbor. So once it has stopped sending the hellos, it will, the two-way communication will not happen for your hellos being exchanged. So that's why your EIGRP neighborship will not form. Okay, any questions over here? All clear?
Yep.
Okay. So here, configuring EIGRP. EIGRP can be configured in two modes. One is your classic EIGRP mode, and another one is your named EIGRP mode. So firstly, I'll cover what is classic EIGRP mode, how it is configured. So in our classic EIGRP mode, the IP routing is a normal command. We need to have in our router, IP routing should be enabled. Okay, by default it is enabled, but your IPv6 routing is not by default enabled. I'll cover IPv6 in a minute. Okay, and these are the commands how to enable your EIGRP in your router EIGRP, and then you need to give a ASN number. This ASN number value can be from, I think, 1 to 65535. These are the possible values. Okay, and post that you can define your EIGRP router ID. Manually you can define, or it will automatically be calculated on the highest loopback IP address. If loopback IP is not there, it will take any other highest IP address from the interface. Okay, then you need to define, then using network statements, you need to identify on which all interfaces I want to run EIGRP. Okay, guys, please pay attention to this network statement. The meaning or the purpose of network statement in EIGRP is to identify my local interfaces on which I want to run EIGRP protocol, on which I want to send EIGRP hello messages. Right?
This is like advertising the network.
No. I'm again saying, please understand, using network statement, I am specifying on which interface I want to run EIGRP. Let's say this is a router R1. Okay, it is connected with multiple routers. R3. Okay, here let's say your subnet is 10.1.2.0/24. Here you have 10.1.3.0/24. Okay, in your network statement, you gave 10.1.2.0 and your wildcard mask. That's it. So what does that mean? An interface which is part of this subnet 10.1.2.0 On that interface only, I will run EIGRP protocol. Void card will be 0.0.0.255.
It's like enabling the interface. EIGRP.
Enabling, yes. Basically, I want to specify on which interface I want to run EIGRP protocol. Because after enabling EIGRP, what happens? I will send hello messages, right? On which interface I want to send hello messages and on which interface I do not want to send hello messages. I'm just specifying that thing.
Okay.
I'm not advertising anything. Okay, guys. First is I'm on which interface I want to run EIGRP. Second thing is I will put this subnet as part of my EIGRP updates. First is on which interface I want to run hello. Second is I will put that as part of my EIGRP update packets. Will I advertise this one 10.13.0 towards R2? No, I won't. Because I'm not running EIGRP onto it. These are the two purposes of network statement. In case of EIGRP and OSPF, it is same. Any question? This is very important. I mean, it's an interview question also. It can be there in your exam also. What is the difference, or please explain the purpose of network statement. This is very important, guys. It's different than how a network statement is used in BGP. It's completely different. Is it clear with everyone? Any doubt? Okay. So next is, if let's say we want to enable EIGRP on all the interfaces, so we can put this statement like network 0.0.0.0. Okay. So any subnet, right? So that's how you can start running EIGRP on all the interfaces, and they will also be advertised in your EIGRP update package. Okay. And
This is
let's
classic.
This is classic EIGRP mode. Okay. Let's say there is an interface. Let's say your loopback 0. So loopback 0 is, I mean, stub kind of interface. It is nowhere connected to anyone. It's just a local to my router. Stub interface basically. Huh? So can I form any neighborship onto loopback 0 or loopback interface?
Yeah, why not?
With whom? Because loopback is nowhere connected. I mean, it does not have any other end. It is just on this router only. It's not a link basically.
But this network will be advertised, right?
Correct. This will be advertised. Yes. If it is part of my network statement, it will be advertised, and it will try to send hello packets also out of this hello, out of this loopback interface. It will try, but they are waste. Right.
Yeah.
So we can define it as a passive interface. Passive is nothing but you want to say that do not send any hello packets on this particular interface.
Oh,
Stop.
okay.
Okay. Stop.
But that network will be advertised in EIGRP, even
Correct.
though
Correct. It will be advertised. Okay.
Okay.
And it can also be used, let's say your LAN interface. You have a switch over here. Okay, you are running HSRP or something, but you're not using any EIGRP neighborship. You want to advertise this subnet over here. You'll declare it as passive. You do not want to send any hello towards your switch, right? but you want to advertise this subnet. You will define it as a passive interface,
Okay.
right? Now, coming to your, this was the configuration for your IPv4. Okay, now if we try to understand your IPv6 configuration. In IPv6, let's say, I mean, the command is IPv6 router EIGRP and then ASN. This is an additional keyword, huh? In comparison to your IPv4 world. Okay, you need to specify IPv6 router EIGRP and then ASN. By default, your IPv6 unicast routing is disabled on your router. You need to enable that. You will get this kind of error message. IPv6 routing is not enabled. As soon as you need to then enable the IPv6 unicast routing. Okay, then only you will be able to configure your IPv6 router EIGRP. Same way, you can configure your router ID. Router ID, okay, this is important. Here also your router ID is 32-bit format. Okay, in IPv6 EIGRP also your router ID is your 32-bit format. It's not in 128-bit format. Okay, please remember. Same way, passive interface you can define. Other thing is, here you are not specifying your network statements. You are on your particular interface itself, you are defining EIGRP. Okay, I am defining that on this interface should be part of EIGRP, this number. That's how you are defining. If you can correlate this thing, this is similar to, I think we have in OSPF also, right?
Yeah.
Okay, IPv6, EIGRP, and then ASN number. That's how we define.
So
Passive
enabling EIGRP on all interface is not possible under IPv6.
Not via single command. Yes, not via single command.
Not it's okay.
Or I mean that kind of hacks we have, interface range. I mean, some shortcuts do we have? Let's say one. With that we can do. But still, I mean, in that scenario also, if we have any other kind of interface, 10 gig or 100 gig, they will need to be manually again. EIGRP need to be configured onto them. But no, not like this. Network statement is not there. Concept of network statement is not there in IPv6 EIGRP routing. Okay, passive interface do not send out or process hello packets. That's what I told you, which prevents EIGRP to form any adjacency on that interface. Can be configured on individual interface or default for all interfaces. Okay, I mean, it is also possible to define passive interface and then we can put default as a keyword. So that will make all the interfaces by default, they will be passive. Then individually you can give no passive interface, something like that. That is also possible. Okay, both the ways are possible. Any question, guys, in EI, this classic mode configuration?
Sorry, the last one, passive interface default. What are we using for this one?
Okay. So let's say in our router, I have FA0 by 0, FA0 by 1, and so on. Let's say FA0 by 20. I have 20 interfaces. Okay, but only on first two interface, or let's say FA0 by 1 and 0 by 2, I want to run EIGRP. So in order to
I see. So
avoid
before
any
we make
mistake,
all the interface, passive interface, and then
correct.
by one enable on each
Yeah.
interface wherever we want
Just to avoid, I mean, in service provider environment or so, we have many interfaces on our devices. So in those scenarios, this is a quite useful technique. By default, make everything as passive, and then remove the passive functionality from the respective interface where you want to run. Okay.
Okay.
That's what I mean. Any other question before we move to the named mode configuration? No? Okay. So in named mode, okay, this is a newer EIGRP mode. This is same. I mean, in case of your IPv6 addressing, you need to enable IPv6 unicast routing. This is same for both IPv4, oh sorry, classic as well as named mode. However, in case of named mode, you can give a name instead of ASN number over here. A router EIGRP, and you can put a name. Okay, in the text format, or you can use any characters. Then after that, you need to define your address family, whether you wanted to run IPv6 based neighborship or IPv4 based neighborship. You need to define that address family, IPv6 or IPv4 unicast. Here you need to define your autonomous system. This is nothing but, I mean, if you compare it with your classic mode, or we were defining our ASN number in the first command itself. But in named mode, we can define it at a later stage. Okay, on two routers, let's say R1, and it is, let's say, connected to R2, and we are using a named mode. Okay, so this name is locally significant. It is, it's not necessary to match this name between these two routers. However, this autonomous system number should match in order to form your neighborship. Right? Yeah. In classic mode also, I mean, you must be knowing that in order to form a neighborship between two routers, this ASN number should match. Yeah. Same way here, in named mode also, we need to have this AS number should match. This name may or may not match, doesn't matter. Okay. Same way we are defining our router ID. Post that, how we are defining our interfaces, we are defining like this: AF-interface and then interface number. All your interface related commands will come over here. Okay, they will be defined over here. For example, you want to declare an interface as passive, you will define like this. If you want to summarize any address, you will summarize like this: summary address, and then give the summarized address. Okay, anything related globally to your EIGRP, that will be defined at this level with your topology base configuration, and under that you will define them. Your hello and hold down timer, they are interface specific, so those configuration will come under this AF interface level. Okay, your authentication will also be configured at interface level. Okay, we can configure authentication between these two devices. We may not have the similar authentication with the other neighbor. So that's why your authentication is also defined at interface level. So that configuration will also come over here. Okay, we'll do that lab also, this one. I'm just giving you a
Sorry,
summary.
Gaurav, can you go back?
Yes, Pramod.
Sorry.
Yes, Pramod.
Why are we setting up unicast communication over here for hello packet?
Why are we? No, it's not for hello packet. We are basically here defining which address family we want to run. Okay, address family IPv6 or IPv4. What is the mode? Because in classic mode, you remember we were having these two different commands. Altogether a different EIGRP I need to run. IPv6 router EIGRP or router EIGRP. For IPv4 it was different, for IPv6 it was different. But in named mode, you can have a single EIGRP domain. Under that, you can run both IPv4 as well as IPv6.
No, it's there is a statement, right? Unicast. I don't know.
Yeah, this is just a keyword. It is not specifying anything with your hello packets. I mean, it does not specify that your hello packets will be unicast. No, it's not like that. It's just a keyword.
Okay, okay.
Okay, it is bounded with your basically your address family, IPv4 unicast or IPv6 unicast. No other significance. Just specifies your address family.
AF interface. What is AF interface?
Address family interface.
Address family.
Okay, AF interface you need to define. I mean, that's how this is the syntax of your named EIGRP mode on which you want to run EIGRP. You need to define that under your address family.
Okay. So for passive interface, there are two commands: interface, then address, IP address definition.
No, sorry, say again, please.
To enable an interface as a passive interface, there are commands, right? First passive interface, and then we need to in the next statement we need to define summary.
No. This is something different. I mean, this is just an example. I told you, in EIGRP, we can summarize a network on a particular interface itself, on any of the interface. Okay, this was the example for that one. However, if I want to define this particular interface as passive, this is the only command. But this will be coming under this AF interface level.
Okay.
You're changing that level, you'll be defining a passive interface. Summary address is a different concept, doing the summarization. Okay, same way authentication also you will define under the interface. Next, I was showing you this EIGRP authentication. Two types of authentication it supports, MD5 and your HMAC. Okay, two steps we need to configure in order to apply the authentication. First is you define a keychain. Okay, keychain is you can understand that within a keychain we can have multiple keys, and each key will have a key string. Okay, this key string is nothing but your password. All right. Then once you have your keychain defined, you need to apply that keychain onto a particular interface. IP authentication mode, EIGRP 100 is your ASN number. Mode you are defining, let's say, as MD5, and then you are applying this keychain on this particular interface. But this authentication should be same on both the ends. This key string or this password should match on both the sides in order to form your neighborship. This is your classic mode configuration. This is an example for your named mode. So same way you are defining your keychain. Then in your named mode, router EIGRP named, you need to go inside your address family, then AF interface default, or if you want to run it on a particular interface, you can give the interface name. If it is default, then on all the interfaces, it will be applied at once. That's how we can configure authentication.
Gaurav, this HMAC is part of Shaw hashing algorithm, right?
Yes. Any question from anybody?
This one actually is not so clear. We just need to learn these commands. There's nothing logical about this, is it?
You need not to even learn. You just need to understand the concept that you need to first define a keychain. Within that keychain, we can have multiple keys. Okay, and each key does have a key string.
So we need to define keychain name.
You need to define a keychain with a name. Under that, you can have multiple keys. Keys are numbered like 1, 2, 3, 4. Then you can define your key string, which is nothing but your password. If you do it your hands-on a couple of times, you will be able to remember these. I mean, you need not to cram this thing. It's easy. Under this keychain also, you can define a lifetime also. Okay, let's say this key string is valid for one particular length. For let's say next 2 months, you can define that. Lifetime can also be defined over here.
Number of
But no-
keys. The number of keys, meaning key 2. What does that mean actually?
There can be, I mean, in the same keychain, we can have multiple keys.
So
I can define a key
I
3 also within the same keychain.
mean MD5 and SHA or something else.
No. MD5 and SHA are the
Okay.
algorithm that I want to apply on a particular interface. This is just an algorithm to encrypt this key.
Yeah.
Okay, but this keychain is we are defining our keys. Basically, passwords. We are keeping more than one password. We can keep more than one passwords within a single keychain.
So only 2 password we can keep under this key.
Not only 2. I mean, we can have more than 2 also. I don't know the exact limit, but there can be many keys that you can configure under a keychain.
Okay, so it is like key 2 is by default is the command.
No.
We can
No,
keep
it's
3,
not.
4, 5, something like that.
This number can be changed. This number can be configured.
Can be anything, right?
Yeah, this will be a number. Basically, I want to say this will not be a string. It will be an integer. This will be a number. While seeing in the lab, we'll check putting a question mark. What could be the range for this number? Any other question from anybody? No? Okay. These are some of the things I want to highlight in order to troubleshoot our EIGRP neighborship. Okay, our EIGRP neighborship, let's say between these two devices, R1 and R2. If first thing is let's say you want to troubleshoot a neighborship between these two, R1 and R2. If this interface is somehow down, definitely your EIGRP neighborship will be down. So interface has to be up state, right? Your interface physically it should be up. Your line protocol should also be up, right? Then what next you can check your autonomous system numbers that you have configured in the EIGRP. They should match. Both routers need to be in same autonomous system, right? Next is network statement. So while configuring EIGRP, you are defining your network statements. So within your network statements, are you correctly, identifying this interface IP or not? It may happen that you have given a different or a wrong network statement under which this IP is not at all coming. Okay, so that thing you can check. We will study about K values also. I mean, if there is a mismatch between the K values on both the sides, these K values signifies which all parameters you want to consider while calculating the metrics. As I told you, by default, it uses bandwidth and delay as the parameters. Rest, MTU, reliability, load, it does not use. So those K values should match between these two devices. We will check that while doing the metric things. They should also match. Okay, passive interface. For example, on one side, I define this interface as passive. Will they form neighborship? No, they won't. Why? Can someone tell me if I define this this interface as passive on R1 and
Hello
I'm
packet.
yes. So by defining an interface as passive, I'll stop sending hello packets or receiving hello packets on this interface. Okay, so that is another thing we can check. Different subnets. Exchanging of hello packets must be done on the same subnet. If not, hello packets are ignored. You remember we spoke about that along with your hello packets, it does send your subnet mask, VLSM support. Okay, so that subnet mask should match between these two interfaces in order to form your EIGRP neighborship. Okay, otherwise your hello packets are ignored. Authentication. If authentication key ID or key string is not matching between these two devices, your hello packets will not get authenticated and they will not form neighborship. Okay, last but not the least, if you have applied any ACL, that is, let's say, denying any EIGRP packets, okay, or you are, since EIGRP works on IP transport protocol number 88, if you have applied any ACL on one side and you are denying those packets, okay, then also it will not be able to form EIGRP. Any question from anybody?
Good.
Okay. AD values. So EIGRP does have, I would say, 3 different routes. I'll tell you first two. One are your internal routes, one are your external routes. So internal, which I'm learning via EIGRP only, that becomes my internal EIGRP routes. And if, let's say, any router is redistributing any other routing protocol, let's say OSPF is being redistributed into EIGRP. So then those kind of routes becomes my external routes with respect to EIGRP. Okay, so internal routes are those injected into EIGRP by the network command. External routes are redistributed into EIGRP from a different routing source. Okay, EIGRP internal and external routes can be distinguished within the routing table by their default AD values. Internal prefixes have their AD value as 90 and your external prefixes have 170 as your AD value by default. Okay, but this value, as I told you, it can also be changed, and this is the command. Distance EIGRP, and then two numbers we can specify. First, we'll specify the AD value of your internal routes. Second is AD value of your external routes. Okay, we can change that. But this is also changed locally on the router. It will not be advertised with our routes. AD is never advertised with our routes. Okay, apart from these two routes, there is another route which is about your summary route. When we perform a summarization in EIGRP, that summary route does have an AD value of 5.
How to define this AD?
Summary.
What is AD?
Which one? This internal and external?
No, administrative distance. What
Uh-huh.
is actually how to define this? This is
the command. If I want to modify, this is the command.
No, I'm not talking about value actually.
How to define? Okay, in words. Okay,
Yeah,
I think you missed.
What is actually this AD?
Okay, you missed the first portion. We covered that. So AD is basically the preference value or the trustworthiness, because you know that a route can be learned via multiple different sources. It can be learned, let's say, via EIGRP, or it can be learned via OSPF. Same route can also be learned via BGP, right? So each among these different protocols, they have their own preference, or I would say their own trustworthiness. Which one is more trustworthy?
I see.
That preference is being defined using this AD. EIGRP have default AD of 90. OSPF has its own 110. Okay, if it is BGP, it may be 20 or 200. Okay. So this AD
what is
value is
170? What is 170 then? It is
170 is external. External. When I'm redistributing any other protocol routes within my EIGRP, those routes will be considered as external EIGRP routes. And how they will be identified? With this AD value of 170, they will be identified as external routes.
Even that other side is also running EIGRP. Still, that
No, not the other side. Let's say this is R1. Okay, and they are connected via EIGRP over here. Okay, but from your R2, let's say, is acting as your border router. Between R2 and R3, let's say you are using OSPF. Okay, and we configure redistribution on R2. So what R2 is doing is R2 is redistributing OSPF routes in EIGRP. So those OSPF routes are, with respect to EIGRP, they are external routes. They are not my internal routes. They are called as external routes. And how they will be identified? By this AD value only. Otherwise, they will be, they will be also called as EIGRP routes. Within my routing table, if I say, okay, they will also be shown as with the code EIGRP. But their AD will be by default 170. All right. If I want to change the default administrative distance in EIGRP, that's how I can do. Okay, and the summary route, if I'm performing any summarization of routes, that route will be having an AD value of 5 by default.
okay.
All right. Any question from anybody? Is it clear? Okay, last concept we'll cover, then we will pause. Split horizon. How we can configure it. Okay. Split horizon, a route definition is a route learned on an interface will not be advertised back from the same interface. Okay, I hope this is already clear, the definition. Okay, if I'm learning a route from one interface, same route, I will not send as an update from the same interface. That is known as split horizon. It is helping distance vector routing protocol in order to avoid the loop. I think Pramod, you also joined when we started this distance vector versus link state. We discussed this split horizon.
Yeah, I joined same time.
Okay, and split horizon prevents advertisement of reverse routes. EIGRP enables split horizon by default. It is enabled on all interfaces, right? It can be disabled on per interface basis. How it can be disabled? In our classic configuration, I think it's not visible to you. Okay, now it is visible. In our no. So in our classic configuration, under the interface itself, I can define like no IP split horizon and then EIGRP and then AS number. Otherwise, in named mode configuration, you remember under router EIGRP name, address family, IPv4 or IPv6 unicast, autonomous system. Under that particular AF interface, we can define no split horizon. That's how we can define. For example, in this topology, what I want to show here is, this is my hub router R1, R2 and R3. So R2 and R1 are forming EIGRP neighborship. Same way R1 and R3 are forming EIGRP neighborship. Okay, R2 routing table, what does it say? Okay, 10.1.1.0. which is lying behind R1. Our next hop is 10.123.1.1, which is this interface. Okay, and its local subnet 10.220/24, which is on its gigabit 0x1. Similarly, on R3 also, route lying behind R1, next hop is 10.123.1.1 gig 0x1. This is my local interface 10.330/24. However, at R1, I have both these local subnets 10.220, 10.330, but these are not being advertised. I mean, R3 subnet is not being found in R2 routing table. Same way, R2 local subnet 10.220 is not part of R3 routing table. Why is it not there? Because of the split horizon rule. Okay, R1 learned this route 10.220 using gig 0, this interface only, but it will not, whatever it has learned, it will not send back via same interface. Okay, then we need to disable the split horizon over here. So once we have disabled, then R2 and R3, okay, sorry, then R2 and R3 does have this route. R2 does have a route about R3 and R3 does have a route about R2. Otherwise, split horizon will prevent that advertisement. This is specifically, I mean, we need to disable this in case of DMVPN configuration. We'll see that in NRC we have this DMVPN configuration. All right. Any question, guys, before we pause for today?
All good, but like there was some topic, like the earlier topic we were discussing about the changing the AD value. So
Yes.
if we change the AD value to a well-defined other AD value, will it take, like for example, if I change this 90 to any of other routing product like 120 or something, will it take?
Sorry, I didn't get your question. Are you saying that instead of 90, if I put 1110 of OSPF?
Yeah, that's it.
Yeah, it will take. It's just a number.
Okay.
It's just a number. It will not clash with OSPF.
Oh,
The only thing is, any route which is learning via OSPF, they will also show that AD value is 110, and via EIGRP they will also show it 110. But they will not. I mean, it will not throw an error.
okay.
It will not throw an error.
Thank you.
Right. So let's have a pause over here. We have completed till slide 13. Okay, how many are remaining before we jump onto a lab? Basically, I wanted to. Okay, let's tomorrow we'll start with a lab. Okay, this will be our lab. We'll configure some of the things. We'll configure this part, this also we'll configure, and then redistribution. I'll tell you redistribution and summarization. Yeah, this we can do tomorrow. Yeah. All right.
So
Metric, we'll do it later.
Gaurav, we done this lab class, lab practical in our Encore as well, right? So this time, what is extra or additional we going to do?
Additional, we'll
No.
be doing IPv4 as well as IPv6. Plus, I think in that Encore summarization was not there. Redistribution also was not there. Okay. And your filtering, route filtering was also not there. EIGRP stub concept was not there. That's what I said. NRC is your advanced routing and services. Basically, any routing protocol, if you take EIGRP, OSPF, they have a lot many things. We cannot cover each and everything, but step by step. And core, you got some base idea. You built some concepts. Okay, why we have static routing protocols? Why we have dynamic routing protocols? What is the difference between them? Okay, in case of dynamic, we have different types of protocol like distance vector, link state. What are their advantages? What are their disadvantages? How we configure EIGRP? Now within EIGRP, how we can tweak, or what all things? I mean, different. We are just doing a double click of each and everything over here. if I show you that syllabus also in NRC, you see in EIGRP, although these topics are similar, I mean, we does have these two things. We does have neighbor relationship. I think this was there in our N core, and some amount of this also we covered RDFD, feasibility condition, successor. Okay, but next this stub, load balancing, metrics, stuck inactive, and how we can troubleshoot these things. Classic and named mode. He is specifically specified in your NRC. Okay, so you should be aware about both of these things.
Okay.
Classic as well as named. Then in classic, both the address families IPv4 v6. Same way in named also, you should be aware about IPv4 as well as IPv6. And not only configuration, you should be, I mean, first you should be aware how to configure, then how to troubleshoot it. Both the things. Because before configuration, you cannot troubleshoot. You should be aware about the concepts first. Then only you will be able to troubleshoot. Okay, this should be the expected behavior, and that's why it is not behaving like this. What could be the reason? So that's where I'm trying to build a base, and we'll move gradually, step by step, towards the rest of the things. All right.
Okay, thank you.
Yeah. Thank you, everyone. Thank you.
Thank you.
You know.
Bye.